My STEM research project investigated the biodegradation of plastics with the help of mealworms, or scientifically known as Tenebrio molitor. Before I begin talking about my project, I would like to thank my instructor, Mrs. Polly Foley and Michelle Kim, for mentoring me throughout the full length of the project and being there for moral support as well. I would also like to thank my classmates for helping me during my experimental process. The purpose of this project is to determine which types of plastics, PS, PP, or LDPE, can be degraded and the rate of degradation. And the purpose is to observe the effectiveness of mealworms and their potential for plastic biodegradation on a larger scale. This project investigated these two topics because of the current increase in plastic use and its inability to biodegrade naturally. This project led me to my hypothesis. Tenebrio molitors are able to biodegrade all three types of plastics tested, but at a rate that is ineffective for large-scale biodegradation. My review of literature began by focusing on plastic. Plastic pollution is an extremely prevalent issue, rapidly deteriorating our environment in irreparable ways. According to NOBOC, they are responsible for 10% of the world's generated waste. This is extremely worrisome because recently manufacturers have been creating more durable, flexible, and longer-lasting plastics through the usage of additives. These additives are extremely effective and cause plastics to break down 400 years after their creation, says Parker. Along with this, there are many types of plastic, 7 to be specific. According to Hardin, the 7 types of plastic include PET or PETE, which are often found in food packaging and fabrics, HDPE, which are used to make cartons, bottles, and building materials, PVC, which is used to make toys and wires, LDPE, which is commonly used to make cling wrap and garbage bags, PP, which is used to make food containers for hot foods, PS, a plastic used to make packagings like egg cartons and shipping material, and finally others, which include most unrecyclable plastics, used to make CDs or eyeglasses, for example. Mealworms, however, have been discovered to be able to digest plastics. Mealworms, Tenebrio molitors, originate from Europe and thrive in warm and dark environments. They are at the larval stage of darkling beetles and have 4 main life stages. This includes egg, larvae, pupae, and their final stage, adult beetle form, says Thevenot. The bacteria in the digestive systems of mealworms have been discovered to be able to digest plastics, says Yang and their colleagues. In order to test out my hypothesis, I used 900 mealworm larvae, 3.5 grams of styrofoam, 3 pieces of 0.5 grams of grocery bags or LDPE, 3.5 gram piece of straw or PP, and 9 plastic containers, latex gloves, disinfectant wipes, a pen, and an electronic balance. For the procedure, 900 Tenebrio molitors, or mealworms, were separated into 9 identical containers with 10 in each container. Holes were poked on the lids of the containers to ensure that oxygen, carbon dioxide, and other gases were able to enter and leave the containers. Each container was labeled 1 through 9, then 0.5 grams of 3 types of common household plastics, styrofoam, plastic bags, and plastic straws, were weighed and then placed in the containers. 3 0.5 gram blocks of styrofoam were measured out and placed in containers 1 through 3. The same was repeated for plastic bags, which were placed in 4 through 6, and plastic straws, which were also weighed and placed in containers 7 through 9. Each week the plastic was weighed and the data was written down, and the containers were cleaned. My independent variables was the different plastic types each group of mealworms were given to consume. My dependent variable was the amount of plastic consumed and the rate of biodegradation. And finally, my constant variables were the amount of mealworms in each container, 100 to be exact. Here are my results. After 2 weeks of data collection, my results were as follows. I started with exactly 0.5 grams of each plastic, and after 1 week, the mass of the styrofoam pieces in each container decreased, decreasing from 0.5 to 0.379 in containers 1, 0.5 to 0.378 in container 2, and decreasing to 0.419 in container 3. It continued to decrease until week 2 when data stopped being collected. The mass of LDPE or plastic bag increased then decreased for all values except for container 6 where the mass continually decreased. For containers with straws, after week 1, the mass of each straw increased and all decreased by week 2. The average mass of the plastics were then calculated by adding up all the data from each row and dividing them by 3, the amount of containers used for each type of plastic. This resulted in PS decreasing in average mass in 2 weeks, LDPE increasing then decreasing in mass, and PP increasing and decreasing in average mass as well. The standard deviation and standard error was to calculate my error bars. Finally, the percent change in mass was calculated to show how much each plastic decreased after 2 weeks. The Tenebrio were able to consume the styrofoam at a rate significantly greater than the two types of plastics. This is shown by the fact that the error bars on the PS line do not intersect or touch any other error bar. The error bars on the LDPE or plastic bags and the PP straws do touch, which show that there isn't a significant difference in the rate of consumption of these two plastics and that any deviation is the cause of random chance or trial error. As shown by my data, there was a weight gain to the plastics. There are 2 factors that contributed to this weight gain. Not all the fecal matter on the plastics were effectively removed, and this could have added to the weight of the plastics. Another possible source of my error in my experiment could have been the death of some larvae and the pupation of larvae. The pupa stage results in the transformation of larvae into pupae, the inactive and non-feeding form stage. This leads to imbalance in the number of mealworms that have the ability to consume the plastics, and all these factors lead to overall inaccurate measurements. Through experiment 1, I was able to fail to reject the first part of my null hypothesis, that the Tenebrio molitors are able to biodegrade all 3 types of plastics tested, and I also rejected the latter half of my null hypothesis due to the overall ineffectiveness of this method. Although this proved to not be a possible solution to large-scale plastic biodegradation, this experiment highlighted an important finding that could lead the world a step closer to discovering a method to degrade plastics on a larger scale. Biodegradation of plastics seemed impossible until types of bacteria in digestive system of Tenebrio were researched. Through further research and experimentation using Tenebrio